Hello class, it's me. I thought I would take a quick second, since I know I'm not there, to go over this story problem with you. I know sometimes that's kind of where we've struggled, and so I wanted to make sure that we're able to go over this together and that we don't get behind. So on 9-5, number 24, I wanted to run through that with you. If you read this problem, it's talking about the number of trout that's caught in a lake. So I'm assuming what they did is they basically took like the time versus number of, fish. And so they found the data from 1995, say 1996, and so on, all the way down to 2014. And how many ever tons, so like maybe this was 8 tons, maybe this was 12 tons. They took all this data, and based on the data, they were able to write an equation, which is what you see here. Okay, so let's not worry really about where this equation came from, but it's really probably coming from some type of a data. So in question A, it says, when were about 15 tons of trout caught in the lake? That is the number for Y, because Y is in tons. So for part A, I'm simply going to plug 15 in for the Y value. So let me just plug this in. Okay, now we basically have to solve this. You'd have to decide your method, because notice it never says what method. Now, it is in the quadratic equation or quadratic formula lesson, so that would probably be your best bet. Well, I would start by moving the 15 over, and so we're going to get 0 is equal to, and then let me rewrite this, and then we get minus 5. Now, we talked yesterday about the discriminant. Remember, the discriminant is going to help you determine the number of solutions. So we're going to go ahead and run the discriminant on this. So this is my A, my B, and my C. So let me type this in. So I do B squared minus 4 times A times C. So my discriminant, notice, is greater than 0. It's a decimal, but it's greater than 0. So I'm going to get 2 solutions. So now we'll go ahead and just solve the quadratic. So the formula, opposite B plus or minus the square root. Now we've already done that part because we have already done the discriminant. So this is the 0.96 divided by 2 times the A value. Now we have to just solve this problem. So if I kind of rewrite it here in our 2 separate pieces, so we have plus the square root part, and I'll go ahead and work this out, 2 times a negative 0.08, so I get negative 0.16, and then I'm also going to have this one, I'm going to have the subtraction of the square root, but my bottom doesn't change. And again, we talked about this yesterday, how you have to be very careful in how you're going to type this into your calculator. So what I'm going to do is kind of in 2 steps. I'm not going to try to type it all in at the same time. So here's my first, the top, then I'm going to divide by a negative 0.16. So I get about 3.88. Now I'm going to solve this one. Only this time I'm just using the subtraction key. And so I get about 16.12. Those are our 2 solutions. And so if you had that, when you check my answer, you might be like, wait a minute, that's not what I see up there. Well, you have to remember that this is in time. So this is really years that's past the starting. So the question says, when was there about 15 tons? Really, after this year. So this is about 4 years. I mean, I guess it really depends on how picky you want to be. But if you look on my answer key, I use this as 4 years. So 4 years plus 1995 would make it go, it'd be at 1999. That's when that many trout was caught. And then again here, I use 16 years plus the 1995. And I got 2011. So those are the 2 answers. However, it's because of these numbers and the way the problem is written. So that's your part A, but notice it's just the quadratic. And even though these were nasty decimals, I still was able to do it, not that hard. All right, let's take a look at part B. Part B says, do you think this model can be used to determine the amount of trout caught in future years? Now, part B may be a little bit hard for you, and here's kind of the reasoning. We haven't done a lot of graphing because the graphing was taught in 9-2. And if you look on the back board, we're going to do that on Friday. So I definitely would not ask you that on the quiz, but I still think it's good for you to think about, okay? So let's go back up to the equation here. If we look at this equation, the intercept is at 10. So this thing, it's going to cross at 10. We know it's opening down, so we know it's probably going down. We could even maybe calculate the vertex if we really wanted to. But how about this? We know the two crossing points were right here. So we know at about 4 and at about 16 is where it crosses, correct? Okay? So if you think about it, we don't know exactly where it starts and we don't exactly know where it goes up. Now we could get it based on the vertex, but if you kind of think about this, okay, it goes like that, and it's crossing at 16. I know my picture's not very good, but you get the idea. The question says, do you think this model can be used to determine the amount of trout count in future years? Well, not really, because 16 years later was 2011. So after the year 2011, wouldn't this be negative trout? That doesn't really make any sense. How are you going to have negative trout caught? So even though this equation might have modeled the data that they collected, it's probably not the best for a real life scenario because it's fish being caught. So we don't ask you to do the explaining ones, but I still think it's good for you to look at this and kind of see that sometimes even though the data may fall into a parabola, it's not always the best representation. Now, the one we did yesterday, remember, was talking about a high jumper. So you have this high jumper that's, standing here and is jumping. Well, this is time, so the graph kind of stops. So this is a better example, okay? The one you're about to do in just a few minutes, you're going to get this quiz review, okay? You're going to be working on this throughout the hour, and if you look on the back, notice you'll see a few more story problems. You've got one about casting a fishing lure, and you have another one about launching a water balloon. So again, if you think about those two scenarios, if you think about a fishing lure, so the person might be standing here, and when they cast their fishing line or lure, notice it's probably somewhere by where their arms are, so it's going to go like that. So that kind of makes more sense than the number of trout caught in a lake because of the way, you would throw your fishing line. So you're going to do some more examples. I want you to think about the story problems, but I also want you to know that they're trying to give you an application. It's not always the best, but they're trying. So for the remaining part of the hour, you guys are going to be working on the quiz review. Well, that's after you check your homework. You're going to work on the quiz review. And remember, we're going to start the class on Friday with the quiz. We're going to start it right away. And then after the quiz, we're going to go back and do 9-2. So have a great day, and everybody work hard, and let's all get an A on this quiz.